The entire worksheet that we're doing today is COP, which is COP. So because it's COP, all these linear functions are going to pass through the origin. So that's where I want you to start. But first I want you to match up your x's with this color. This is my color, whatever color you want to choose. This is my x line. So all these values are going to go here in this table, x with x. Now I'm going to use this blue one for my y. This is my y. So we're going to start making our points down our line, which are these, which we've done before. The first point that I want you to put, and this is where always I want you to start, is at this point right here. So skip a couple because we're going to mark these two here. So start at the third one. So this point, this name right here is 0, 0. He's caught because he passes through that origin. That's the name of it, the origin. That's how we know that this is COP. We're going to deal with constant proportionality each one. So constant proportionality is K equals Y over X, which is rise over run. He has the same name, we just have to find him. Now we're finding him through this graph. So if I travel my line and I look for the first line where it meets right there in that corner, it's this point right here. That's that point. Let me zoom in. That point right there. There's my point. What's this guy's name? Well, you have to put the x in first. So he falls right here on 5. He partners up with 1 as that y. So I keep traveling until I run into my next coordinate, which meets right here in that corner. His name for the x, because that's what they're asking for, his name for x, that's why I color-coded matching them. This is 10, and he pairs up with 2 for my y. That's why I have them highlighted, colored, matching up just like you should be doing on this assignment. They need to be matched up. You don't have to have purple with purple for this. Pick any other color as long as there are 2 colors matching your x and your y. Now let's fit in another coordinate point. If I go, it's right here. And this coordinate point, so this was this point right here. His name was XY. His name was 5, 1. This guy's name was 10, 2. This guy's name was 15, 3. Now there's 2 ways you can find the rise over the run or the COP. You can find the change in values of these, or you can do the rise over the run. How do I get from here, from this point to this point? Well, I went up 1 unit, so from 0 to 1 is 1. So that's rise, rise, run. I rise 1 and I ran 1, 2, 3, 4, 5. I went up 1 unit and I ran 5 units. So to get from here to here, that means you too are going to rise another 1 unit. This is that one little square right here is 1 unit. And you're going to run 5. 1, 2, 3, 4, 5. Hey, what do you know? It met there at your next point. Same thing to get from this point to this point. I rise up 1 and I run 5. So your rise is 1, your run is 5. So what's COP's name on this one? COP's name for this one is y equals 1 over 5x. Now, do you see how these coordinates are empty? Well, because you have to work backwards. So if you're going forward, which is positive, he's going up, 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 right? He's going 5, 10, 15, 1, 2, 3. If I'm going to go back, so what's the opposite of positive? Well, I have to go negative. So then I would have to go down 1 and run 5. So what's this guy's name? He is called 5, negative 5, and negative 1. How did I get this? Again, you see where this line meets, where this corner meets, you put the x first. So his name for this one was negative 5, because I'm on the negative side now, negative 5. But you see how this line is now in the negatives. Negative 5, this is my y line. Well, where does he cross through here? Well, that negative 1. Negative 5, negative 1. I can squeeze in one more coordinate, which is this one right here. Again, I went up 1, I ran 5 to the right. So then it would be the opposite. So instead of going up, I would go down 1. And instead of going to the right, because obviously there's no line here, right? If I were to go to the right and put it here, the line's over here. So I go down 1 and I go 5 to the left. This is my next point, but I mean, either way, clearly you can see that this line meets right there in that corner. So what is this point's name? His name starts with the x, which is lined up right here, which is negative 10, and 2, negative 2. Now, just by starting here, let's say you couldn't go backwards, let's say you got really lost there. What's happening in the change here? How are we doing that in the previous assignment that we did? From here to here, they're adding 1. From here to here, they added 1. From here to here, they added 1, right? From 0 to 5, they added positive 5. From 5 to 10, they added 5. From 10 to 15, they added 5. So what's the change in y? Every time they were going by 1, the change in x, they're going by 5. Again, you can do this here. So if you're going up in order to go positive, how would you go al revés, backwards? You would say, well, instead of adding 1, I would minus 1, which would be negative 1. If I want to go up one more, to go backwards, I'm taking away now, because going positive would be adding, because that's the opposite. Going back would be minus, right? So this would be minus 1, which would be negative 1 minus 1 is negative 2. Go backwards, instead of adding 5, I would take away 5. 0 minus negative 5. 0 minus negative 5 gives me negative 5, which is that one right there. How do I get from negative 5 to negative 10? What did I do there? Well, again, instead of adding 5, because I'm going positive, I'm going back, which is the opposite of positive, which would be negative. I took away 5 from here, so again, I'm going to take away 5. So negative 5 minus negative 5 gives me negative 10. So recap, what did I do? This is where you start. You plug this in here. This is where you start. You know he's a COP because he goes through the origin, which is 0, 0, right? You find your next point, which is where that line passes through that corner on the back of the graph. His name, 0, 0 for the origin, his name for this one was 5, 1. How did you get from this point to this point? That's how you can find your rise over your 1. You run up 1, ran 1, rise 1, rise 1, run 5. So the next one, I'll start you off. Where would I start from here? No, match them up first. I better see you highlighting like crazy today in class. That matches that. That's the same color. And this is my now we can start. So where are we starting? This line's passing through the origin. Give it about 1, 2 spaces, 0, 0, right? Get your fingers, start traveling with this line. Traveling, 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 traveling. This line right here, let me zoom in. You see how this line is going? It doesn't pass through this corner here. It doesn't pass through this corner. It passes this corner right here. What's this point's name? Well, his name is X, which is positive 3, and Y is 2. Right? Now we have our 2 points where we can say, well, what did I rise and what did I run in order to find Kopp's name? You can find Kopp's name through here, and you can also find Kopp's name through here, but I want you to do it both so you can label those. So my rise over my run from 0, so this is where he crosses, so I went up 1, 2 units, that's 2. I rised 2 units, and I ran 1, 2, 3. I ran 3 units. So this is my Kopp's name. To get to each point, I'm going to rise 2, 1, 2, and I'm going to run 3, 1, 2, 3. That's your next coordinate point. Rise 2, run 3. Rise 2, run 3. So then this one would be rise 2, run 3. This is my next point. I want to know these points' name. We wrote this one down. We wrote this one down. What is this next one's name? 6 and 4. This point's name is 9 and 6. Now, this is changing. The change in Y is 2. So that means every time you're changing, they're going to add positive 2. They're going to add positive 2. 2, 3, 4, that's 2. 4, 5, 6, that's adding 2. Then the X for the run means you're going to add 3. Add 3. Yes, that's true. Add 3. Yes, that's true. Add 3. If we're going up and we're adding, how do I go backwards to find this point? If it's not on the graph, I can find it on the graph, which is just going right here and looking for where he meets that point, right? His point for the X is -3 and -2. But let's say I don't want to find it on this graph. Let's say I only want to do this here. So the change is now this is positive. Now to do it backwards, I would have to say, instead of plus, I would say -2. So then I go here, I would say -2. So what's -2 minus 2? -4. Instead of adding 3, I would subtract 3. So -3 minus 3 would give me -6. I'm not too sure on this, Miss Lozano. Well, just go back over here. Instead of going up 2, you would go down 1, 2. And run, instead of going to the right, you would go to the left 1, 2, 3, which is -6 and -4. -6, -4. Finish the rest.